Welcome to the damp tuning fork video. In exercise 1, we'll be using Lissajous Vickers to determine the tuning fork frequency.
First, use a T connector on the function generator to connect it to a speaker as well as the oscilloscope. Connect the microphone to the other channel of the oscilloscope. Press display and change the format to XY.
Turn on the function generator. Strike the tuning fork and hold it up to the microphone. Adjust the oscilloscope channel 1 and channel 2 levels and adjust the frequency on the function generator until you get as stable an ellipse as possible. If your tuning fork has a frequency listed on it, you may use this as a rough guide, but note that it is likely not exact.
In exercise 2, we'll be using two tuning forks to produce beats and measuring the beat frequency.
Plug the sound sensor into the data acquisition interface.
Open Data Studio and click Create Experiment. Add the sound sensor and ensure that the sample rate is reasonable. Remember, a good rule of thumb is that your sample rate should be at least twice as large as the highest frequency you want to capture. Create a graph of voltage versus time.
Hold two tuning forks that produce audible beats near the sound sensor, press Start in Data Studio, and strike each fork in succession. Record at least 10 periods of the beat frequency and press Stop.
In exercise 3, we'll be measuring the damping coefficients and Q factors for different tuning forks.
Clamp a tuning fork to a stand and using whatever hardware is necessary, clamp a sound sensor nearby. It is important that the distance from the tuning fork to the sensor remain constant throughout recording data.
In Data Studio, use the Data drop-down menu to hide the old data and press Start. Strike the tuning fork and capture enough data to observe damping. Repeat for 5 different tuning forks.
In exercise 4, we'll be measuring the decay of sound vibrations over distance.
Using additional hardware as appropriate, set up 3 sound sensors at different distances from the tuning fork. Try not to get them in the way of each other as we're attempting to measure the effective distance. Plug the additional sensors into the data acquisition interface. You should also measure the distance from the tuning fork to each sensor. Note that we are assuming the sensors all have the same sensitivity. If your data is problematic, you may need to devise a scheme to reference one sensor to another.
In Data Studio, press Setup and add the additional sensors. Drag the 2 new voltage traces into the graph and hide the old data. Press Start and strike the tuning fork. Record enough data to capture damping at each distance.
What did one electron say to the other electron? Don't get excited, you'll only get into a state.